Hello, we are discussing about GATE 2013 ECE paper. For the given circuit, we are going to find out these two values VYZ1 by VWX1, VWX2 by VYZ2. Given that one VWX1 is 100 volts and VYZ2 is also 100 volts. We are going to calculate VYZ1 when VWX1 is 100 volts and we are going to calculate VWX2 when VYZ2 is 100 volts. And these ratios we are going to find. Okay, so what is the value of VYZ1 when VWX1 is 100? This is first case. If voltage 100 volts is applied across W and X terminals, what will be the value of Y and Z? Next case is when you are applying a voltage on secondary side, that is across Y and Z terminals, what will be the expected voltage across WX? Okay, so first this circuit diagram consisting of two parts. One is ideal transformer followed by attenuator. Attenuator which reduces the gain. Output of attenuator is always lesser than 1. Okay, attenuates means reducing. So whatever the input you are applying for attenuator, output will be definitely lesser than the input. Okay, so gain for that one is always less than 1. Here it is attenuator. Okay, say this is primary of transformer VP and it is secondary of transformer Vs plus minus. Secondary of transformer is input for this attenuator. This is what attenuator. Okay, so VYZ can be written as 0.8 times of Vs. Okay, so if VWX, that is nothing but VP, VWX1 which is nothing but VP, that has given as 100 volts. Okay, then this is turns ratio 1:1.25 which is nothing but primary turns and secondary turns. We know the relationship. Okay, V primary by V secondary is equal to N primary divided by N secondary. Okay, from this one we can get the ratio of Vs. Vs is equal to VP into Ns divided by Np. Vp is primary voltage which is 100 into Ns secondary turns 1.25 divided by primary turns 1. So 125 into 100 is 125, 1.25 into 100 divided by 1. So secondary side voltage is 125. Next Vs is known 125 volts. From this one we are going to calculate VYZ when VWX1 is 100 volts. First case which is nothing but we can write it as 0.8 times of Vs. So this is 0.8 into 125 which is equal to 100 volts. So whenever VWX1 is 100 volts, okay, by that time VYZ1 is also getting it as 100 volts. So 100 by 100 can be one of the option. So either B or C can be answers. Okay. Now we are going to find VWX2 by VYZ2 and VYZ2 is given as 100 volts. Now we are applying voltage across output of attenuator. We are going to find the voltage across primary side of transformer. Okay. This is second case. We can say that one it is VYZ2 which is nothing but 100 volts it is applying. Okay, and it is secondary side voltage Vs and this is VWX2 which is nothing but primary voltage. Okay, and it is attenuator. We can think it as above is going to be resistance R1 and below is resistance R2. So the same circuit can be drawn like this. This is ideal transformer and attenuator I am writing in this way. This is R1 and one more resistor is R2. Okay, and voltage across R2 is VYZ2 which is given as 100 volts. Now if you apply voltage across this one, that is plus minus, then current flows in this direction. Okay, current flows into the circuit in this way. Whenever current is flowing through this one, okay, so you may expect that one this current is going to making some voltage drop across this one. Okay, so that you may get some voltage across this one. That way you are going to find. But you must know this secondary is going to be acting as inductor. Inductor has a property. Okay, inductor opposes sudden changes in current. Inductor opposes sudden changes in current. Whenever you are applying 100 volts, at that time the current flowing through this is going to be 0. Okay, because before application of 100 volts, let us assume 0 minus, that is equal to 0, and this is the same current which is flowing after application of the voltage also. So current flowing through this one is 0. Whenever 0 current is flowing through this resistor, at that time voltage across R1 is going to be I into R, that is I of 0 plus into R, which is 0 volts. 0 volts is nothing but it is acting as short circuit. So simply this is equivalent to the resistor is replacing with a short circuit. Okay, now the resistor is replacing with a short circuit. Whenever it is replacing with a short circuit, the same VYZ2 that is going to be available across the secondary. Now Vs is going to be same as VYZ2, that is 100 volts. And we know the ratio, this is NP is NS, primary turns and secondary turns, and this is Vp. Vp is nothing but VWX2. So we get the ratio of VWX2 divided by Vs. Okay, which is nothing but Vp by Vs is equal to Np by Ns. Okay, Vs is known 100 volts, so you can calculate Vp, which is nothing but VWX2, that is equal to Vs into Np divided by Ns. So Vs is 100 and Np primary side 1 and Ns is 1.25. So 100 by 1.25, which is nothing but 80 volts. So primary side voltage is 80 volts when voltage across YZ terminals is 100. So we get the ratio as, the ratio is VYZ2 divided by VWX2 is equal to 100 by 80. So the final answer for this question is 100 by 100, and VWX2 is 80 and VYZ2 is 100. So you will get it as 80 by 100 and 100 by 100. So this is the right answer. B is the right answer for this question. B is the right answer. Thank you.